Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing chapter 12D, question 8. So this is to help you cover the basics of projectile motion, which is part of your vector calculus, vector function chapter, and this is very common in the exam. So I just need to make sure that all of you guys, especially the special students, and if you do physics, this is also, I guess it helps a little bit, to understand and to know how to answer these type of questions. So let's have a go. Question 8. The position vector, so RT, of a projectile at time t is given by this position vector right here. There's only two components, I and j. That means I is the horizontal and j is the vertical. That's our assumption. For t bigger than 0, so time is positive. If the projectile is initially at ground level, find A, the time taken to return to the ground. So let's answer part A. This is very quick. We want to know when the projectile, so the projectile starts off at the ground, so I'm going to draw a quick axis right here. It's going to start here and then it's going to travel, and then it's going to come back and hit the ground, right? So that's pretty much every kind of projectile. When you throw it, it starts from the ground and then eventually ends over here. We want to find the time that it reaches the ground again. So if you want to do that, you look at the j component. So what is the vertical height once it reaches the ground again? Well, you let the j component, so that's 300t minus 4.9t squared, you let that equals to 0 because 0j means you're on the ground, okay? So you sub that, put that inside your calculator, your answer should be t equals 0 or t equals to 3,000 over 49, and that is in seconds. Okay, so that's part A. The time taken to return to the ground. If you want to answer it clearly, then just circle this one right here. It's a 3,000 over 49. Now let's do part B. The speed at which the object hits the ground. So when it touches the ground right here, as the moment it touches the ground, we want to find the speed, which means the magnitude of the velocity. Okay, so if you want to do that, we need to make sure we find the velocity vector first. So we have the position vector, which is 400ti plus 300t minus 4.9t squared j. If you want to find the velocity vector, you differentiate your position vector. So differentiate 400ti, we get 400i. Differentiate this j component, we get plus 300. So I'll put a bracket so that's easy to see. Minus 9.8t, and then that will be vector j. Now, if you want to find the speed at which the object hits the ground, you need to find the velocity first. So that means velocity, we know it hits the ground at 3,000 over 49 right there, okay, in seconds. So we just, we want to find the velocity vector for that. So sub it in, and guys, if you sub t over here, your answer should be negative 300j. Okay, now this is only velocity. We want to find the speed. If you want to find the speed, guys, this is an important concept. You just find the magnitude of your velocity vector at that time, okay? So at 3,000 over 49 seconds. So we find the magnitude of a vector. Well, we've done that in chapter 2. You just square your coefficient. So that's 400 squared plus negative 300 squared, but negative square is the same as positive square, so I'll just write as positive, and your final answer should be 500 meters per second right there, okay? So that's your speed. So the projectile hits the ground at 3,000 over 49 seconds at a speed of 500 meters per second. Now let's answer part C. So this is a really great one. Part C asks you for the maximum height reached. Now, if you want to find the maximum height, as we learned in kinematics, is when your velocity of the object as it's traveling reaches 0, okay? When velocity becomes 0, and then it will fall back down. So the highest height the object goes is when velocity is equals to 0. Now, the thing is, your velocity over here, how do you know which component you should let equals to 0? Well, we talk about the height component. The height component of your position velocity vector is the most important, okay? So we differentiate our position, we already got our velocity, and you let the j component equal to 0. The velocity, the j component of the velocity vector equal to 0. That's when you get this maximum height right here, okay? So that means 300 minus 9.8t equals to 0, and then you solve for t. If you do that, guys, it is 1,500 over 49 seconds, right? Or if you do physics, I guess you can find a shortcut. Every projectile motion, just divide the time that reaches the ground by 2, and then you should be able to get your highest point. But in special, it's very simple. Just let the j component of your velocity, make sure it's not the position. If you let the j component of your position vector equal 0, you're just finding when it hits the ground. If you let your j component of the velocity vector equal to 0, then you're finding the highest height. See, over here, okay? When your diff is equal to 0. Now, part D, let's have a go. Oh, actually, we haven't finished part C yet. We need to find the maximum height. So maximum height occurs at t equals 1,500 over 49. If you want to find the height, then all we need to do is sub this back into the height component. So 300 times by 1,500 over 49, and then minus 4.9 times by another 1,500 over 49 square. Chuck inside your calculator, guys, and you should get 225,049. So that is the height of this, and it's in meters. Okay, so let's do part D. We want to find the initial speed of the object. That's very similar to part B. So initial speed of the object means your velocity must be at time 0. Okay, so we want to find the initial. So you sub in 0 over here, and what you get is 400i plus 300j. Very simple. Okay, sub in t equals 0. And afterwards, if you want to find speed, as we know, we get the magnitude of your velocity vector, and it's actually the same answer. So 400 square plus 300 square under the square root, you should get 500 meters per second. The only difference between part B and D was your velocity here was going up, and in part B, your velocity was going down. Part B, your velocity was going up, okay? Because your projectile, it's just a motion. That's how it works. Now, the reason why we did part D was to help us answer part E. What does part E say? The initial angle of the projection from the horizontal. Okay, so how does that work? Well, we want to know when I throw the object, or when you're throwing the object from ground, okay, what is the angle, initial angle that it makes with the horizontal, okay? What's that theta right there? If you want to do that, guys, very simple. We learned in vectors, how do you find the angle between the vector and the axis? It's just cos theta equals to your x, so your horizontal component, we'll call that x, divided by the magnitude of the vector itself, okay? So in this case, magnitude of velocity vector. So now let's have a look. Cos theta, theta is what we want to find, equals to what is the coefficient? So the coefficient of your horizontal position right here is 400. So at the start, coefficient, we're throwing it at 400i plus 300j. The j is not counted. We only want what the angle makes with the horizontal, okay? So the x-axis right here. So 400 divided by the magnitude. The magnitude we know is the speed, which is 500. Make sure you use velocity. Whenever you're talking about angles of motion, the angle that it makes when you're throwing the projectile, you have to use velocity. Not position, not acceleration, velocity, okay? Now, of course, just solve for theta, cos inverse of that, guys, and you should get 36.87 degrees, right? Okay, so that's it to answer question 8. Hopefully you guys found this video useful. It is the foundation to projectile motion, and if you did find it useful, make sure you leave a like and a thumbs up and a comment if you want. But aside from that, guys, I'll see you in the next video. Thanks for watching.